Hi guys, in this video I'm going to go over wave behaviors. So we know that waves are organized transfer of energy. So when we're talking about a behavior, what we're really saying is what does a wave do when it strikes a new medium? Remember that the medium is the matter that the wave is traveling through. So there are a few different things that can happen when a wave hits a new medium. So over here on the side, I've got this box is kind of representing a new medium. So maybe if this was air, then this could be a wall, okay, or a pane of glass or whatever. So the first thing that can happen when a wave strikes a new medium is it can be reflected. So in reflection, we would say the wave bounces off. The new medium. So I'm going to use a ray model for light. So even though light's a wave, we can use a straight arrow to represent the path of the light wave. So let's say the wave comes in, it hits the surface and it reflects. It just bounces off, okay? Now the next thing that could happen is the wave could be absorbed. So remember that waves are energy. So in absorption, the energy of the wave is transferred into the new medium. Oops. Okay, so let's say I've got this wave light and it hits it and it gets absorbed. So the energy just kind of transfers. So you don't really, it doesn't go anywhere after that. It gets into the material, okay? Another thing that can happen, the third thing really that can happen is it can be transmitted or retransmission, okay? So with transmission, that's when, let's choose another color. The transmission, the wave passes through. It's transmitted. Okay. So let's say this wave is going to be transmitted, so it's going to hit the new medium and nothing's going to happen. It's just going to keep on going. It passes through. Okay. Now here's the thing. Remember that speed is controlled by the properties of the medium. So if it was in air out here, and let's say that this was a pane of glass, when it passes through into the pane of glass, that's a new medium, that's new matter, and matter is what controls the speed. So sometimes, depending on what matter the wave was in and what kind of matter it's passing through, something special can happen when it gets transmitted. Sometimes it can get refracted. So in refraction is a special kind of transmission. And in refraction, when the wave passes through, it gets bent. Okay, so let's say this wave's going to come through and it's going to pass through, but when it passes through, it gets bent a little. It doesn't go quite the same way. So you see how it shifts, and then of course it comes out into this third medium, and see how it's off a little bit, okay? This is really important because this is why we can see rainbows. So let's say we have a prism, and what happens is the light comes in and it gets bent, and then it gets bent again. And the thing is that different wavelengths of light get bent at different angles. So when it comes in, of course, white light, you'll remember, is made up of all the colors. But as it's coming in here, it's coming in at the same, all together, but they get bent slightly differently. And so those colors start to get spread out. And then when I get to the other side, now you can see all those other colors. Pretty cool, huh? Now let's see an example of how this works, okay, and how this affects our vision. So let's say we've got this apple, okay? And remember, you can't see anything unless it enters your eye. So let's add an eye. Okay, let's say that's your eye. okay? So as the light comes in, let's remember that white light is made up of all the lights, but I'm just going to use red, green, and blue, to do this example to make it simpler, okay? So as the blue light comes in and it strikes this apple, it gets absorbed by the apple. The energy from the blue light gets taken into the apple. As the green light's coming, remember it's coming too because white light is made up of all those things, the green light also gets absorbed. But as the red light is coming in along with the other two, it doesn't get absorbed, it gets reflected. And that's why the apple appears red, because the red light is the only one not being absorbed by the apple. It's being reflected, it's bouncing off the apple in order to enter your eye. You can't see anything unless light comes into your eye. So a color appears, an object has a color because that's the wavelength of light that's being reflected by that object. Okay. All right, thanks for watching.